The directions for these would be to solve. Now what you're looking at here is that if you look at this problem, we're going to be solving these by factoring, because if you look on the side directions, which I kind of cut off right over here, it says solve by factoring. So the first thing you want to do is factor this. Notice that it's a binomial, that these are perfect squares, and it's a difference, which means this is a difference of two squares. So when we factor this, if you'll remember, we take the square root of the first term, which would be 2x, and we write it in the front. Then we take the square root of the second term, which is 3, we write it in the back. And then one has got to be positive and one has got to be negative, because they're like the conjugate. They're going to cancel out those middle terms. Now that we've got this in factored form, you're going to set both of these equal to 0. So we have 2x plus 3 equals 0, so we subtract 3 from both sides, so 2x is equal to negative 3. Divide both sides by 2, and x is equal to negative 3 halves. We also do that same thing here, where we have 2x minus 3 equals 0. Add 3 to both sides, we get 2x equals 3. Divide both sides by 2, and x is equal to 3 halves. So my two answers are going to be x is equal to negative 3 halves, and x is equal to positive 3 halves. On number 2, with this problem, you are going to need to look at what you're given. First off, this is not in standard form, so we need to make it in standard form. 2x squared plus x. Now when I move that 6 to the other side, I'm going to subtract it from both sides, so that's what I get. It's now going to equal 0. And then notice that the coefficient of a is something larger than 1. So we can do our factor x, where our beginning value goes one place in our factor x, and then 2 times negative 6 is negative 12. And so now you got to figure out what two numbers multiply together to give you negative 12, but still have a sum of 1. 4 and 3 are going to give us 12. Which one of those should be negative to give me a positive 1 here? Here. So 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So now you can have your x plus 4 times your x minus 3 equals 0. But this had a coefficient other than 1, so don't forget to divide that a out again. So what we're going to get is x plus 2 times, we're going to slip that to the front, 2x minus 3 equals 0. And now you've got to solve both equations. So when we solve this, the first one we're going to have is x plus 2 equals 0. When we subtract 2 from both sides, we get x equals negative 2. Then we have the second equation, 2x minus 3 equals 0. So add 3 to both sides, and 2x is equal to positive 3. Divide both sides by 2, and x is equal to 3 halves. So one solution is x equals 3 halves. The other solution is x equals negative 2. All right, if you look at number 3. Number 3, this is also out of form. So we need to go ahead and put this back in standard form. So we're going to add 4x to both sides. So we get negative 4x squared plus 4x. We're also going to add the 15 to both sides. So plus 15 is equal to 0. So all I did was move the 4x over to here by doing its opposite, adding 4x. And I moved the 15 to the left side as well by doing its opposite, adding 15. And again, you want to check here, do you have a GCF? We don't. So now you're ready. We really need to be doing the factor x again. So here we have a 4 here. Our beginning value is 4. And then we have negative 4 times 15, which is negative 60. So now we have to think of two numbers that multiply together to give me negative 60, but add together to give me 4. And those numbers are going to be 10 and 6, and because 4 is positive, the 6 is going to be the one that's negative. So then we're going to do the same thing where we have our x plus 10 times our x minus 6. But don't forget to divide out your a. Our a was this 4. Divide it from both sides. Simplify. X plus 5 halves times x minus 3 halves equals 0. And then we're going to slip this to the front.